What's up, all you mathletes? Welcome to section 3.2a, solves linear systems algebraically using substitution. We're going to do the exact same thing. We're going to accomplish the same goal as we did last section. Last section, you remember, there were two systems, a system of two equations and two unknowns, x and y. We had to find the pair of values, like x and y, that solve both of them at the same time. Well, we're going to do the same thing here. We'll have a system of two equations and two unknowns, and we will arrive at the answer, which is going to be like a pair of numbers that solves both at the same time. Except we're not going to do it using graphing. We're going to do it using substitution. Let me show you what I mean with a word problem. And you know what? I love word problems. Maybe I know word problems can be a bit difficult sometimes, but if you ever actually have to use math in the real world, it's going to come in the form of a word problem. So let's get good at doing it. Food truck Angie sold a total of 240 hamburgers and cheeseburgers. Total is going to be a big word in systems of equations. This section, next section, anytime you see the word total, that's going to be your clue as to how to construct the equation. I'll show you how in a second. Angie sold a total of 240 hamburgers and cheeseburgers. Coincidentally, she estimates that she sold twice as many cheeseburgers as hamburgers. So how many of each does she estimate she sold? So let's write down our givens. Total of 240 sandwiches and 2 times more cheeseburgers than hamburgers. The unknowns are going to be H hamburgers and C cheeseburgers. I think that's just, it's better to use H and C than X and Y, because then it's a lot easier to remember which one is which. All right, let's keep going. So total is going to be, I know that H plus C is equal to 240. The total number of hamburgers plus the number of cheeseburgers is going to be the total number of sandwiches combined. And so that's why, first of all, it's really important to make sure you don't skip this unknown step. H, C, write it out. H is hamburgers, C is cheeseburgers. Because if you don't do that, then this part is impossible. How are you going to write this equation if you don't have recognized what H and C are going to be? Once you fully define H and C, once you write them out, then you can see, the total H plus C is going to equal 240. This next one's a little trickier. 2 times more C than H. And I'm going to say, you might be tempted to see that 2 is next to C and further away than H. Like that's the natural inclination. Even in the word problem, it says she sold twice as many cheeseburgers. And if you stop there and write 2C down, it's actually going to be incorrect. Because really what's happening is you have the small number here is being multiplied by 2 to get the big number. If you had, let's just put some numbers on it. If you had 50 hamburgers, then you'd have twice as many cheeseburgers. That's 100. So 2 times the number of hamburgers is going to be equal to the number of cheeseburgers. And it's tricky because, like I said, in the way the sentence is constructed in the English language, it's the twice, 2 times, and the cheeseburgers are closest to each other. But that doesn't mean it's 2C. It's actually 2H. Let's keep going. Now, substitution is going to be, it works really well when you have a variable all by itself. So in this equation, for example, you have 2 and the multiplication of H, but on the other side, you have C. And that's great. Anytime you see a variable all by itself already solved for, then that's an indicator that you should use substitution. And what it looks like is like this. You're going to see, now that you know what C is equal to 2H, you're going to rewrite the top equation, and instead of writing C, you're going to write what C is equal to. What is C equal to? I don't know the number yet, but I do know that it's equal to 2H. So watch me rewrite this top equation, the red one, and instead of C, I put what C is equal to, 2H, which might seem like a tricky move, but what we've done now is we've created one equation with one unknown. H plus 2H is equal to 240. If you want to simplify, you get 3H, and then dividing both sides by 3, you get H is equal to 80. Yay! Now, you're not done, because although you know how many hamburgers, you got to also figure out how many cheeseburgers. Fortunately, you can just use this blue equation, plugging 80 back in. 2 times, I now know what H is, it's 80, is equal to C. So therefore, C is equal to 160. And the way you can often report this is very similar to when you're graphing. You write it down often in alphabetical order. So like X comes before Y, and so it goes X comma Y, and C comes before H. So we're going to go 160 comma 80. This is 160 and 80 are the two numbers that satisfy this system. Both equations are true both at the same time. And you could check it if you want. You could plug them back in. All right, let's keep going. Next word problem, bake sale. Cassandra and Alberto are selling pies for a fundraiser. Cassandra sold 3 small pies and 14 large pies for a total of $203. Alberto sold 11 small pies and 11 large pies for a total of $220. Determine the cost of each pie. All right, so let's. There's a lot going on here, so really, it's incredibly important to get organized. And I really like using the GUESS method. I'm actually going to write down the unknowns first. Determine the cost of each pie. You just look at the question, the cost of each pie. So I know there's 2 different kinds of pies. We got small pies and large pies. So S is going to be the cost of the small, and B is going to be the cost of the big or the large pie. I think I didn't want to use L because L looks like 1. So B is just different. So cost of a big pie, same thing as cost of a large pie. Anyway, unknowns. And then actually maybe we should do my givens next. So givens, I've got all these numbers here, 3, 14, 11, 11, and how much they got total. So the way you know how to organize is the total is going to go all the way at the end. So Alberto, for example, had a total of $220. Put all that by itself, and he got that by doing 11 small pies and 11 big pies. Cassandra, same thing. Her total is $203. She got that by selling 3 small pies. I don't know how much they cost. That's unknown. But I can say 3 pies times their cost plus 14 pies times its cost is going to equal the total. Okay, so what we have to do now is we have to get one of these variables all by itself. It's a step we didn't have to do over here because C was already alone. It was already solved for itself. But here we have to actually choose this S or this S or this B or this B to solve the equation and get it by itself. And I think I'm going to choose the red one because I noticed that 11, 11, and this is also divisible by 11. I think I can just divide that top red equation by 11. To get everything by itself. So yeah, 11s, you have to divide, remember when you multiply or divide an equation, you have to do it for each term on both sides. So this is this divided by 11, this divided by 11, and this divided by 11. And boom. So you can see, what I'd like you to do underneath the red dot is to figure out what is there. But in any case, 11s divided by 11 is S. 11b divided by 11 is B. And now, actually, you can solve this much more easily. I'm just going to choose to bring the S over, so therefore B is all by itself. And now that we've solved this equation for B, it's going to be a lot easier to substitute into the other equation. I'm going to write this other equation down. 3S is just the same copied. However, I'm going to write it again. And instead of writing B, I'm going to write what B is equal to. It's equal to 20 minus S. And there it is. These two equations are both the blue equation, and instead of B, I wrote what B is equal to, 20 minus S. This is the key move. It's the hardest one to remember, hardest one to get right, but it's critical. It's the central part of it. I used parentheses here. Those weren't mathematically very necessary. It could have just written H plus 2H with no parentheses. But here, it's absolutely critical to use parentheses. So I've just gotten in the habit of using parentheses every time I substitute something in, whether it be a number or a variable expression like this, 20 minus S. So this might look like things got trickier and more complicated because we had this parentheses and subtraction where we didn't have it before. But the great thing about this equation, it's one equation on one own, and we know how to solve it. I think I'm going to distribute first, and then for 14 times 20 and 14 times S. And then I'm going to combine the like terms to get 280. Positive 3s minus 14s gives you minus 11s. And then I'm going to subtract 280 from both sides and divide both sides by negative 11. You get s is equal to 7. It'd be kind of a red flag if you got like a negative number or a decimal because there's no way that s could be. It could be like a. it could be like $7.50, but here S we're saying is S is the cost of a small, and it's going to be exactly $7. It'd be a red flag if you got like 7/3 of a dollar, or some sort of decimal that doesn't round very easily to the nearest cent. Anyway, you know this, and you can't stop here. Even though you've got half the answer, you know what S is. You also got to figure out what B is. So take it and plug it back into, say, like this equation looks pretty easy. Like, in order to figure out what B is, I'm just going to take this 7, put it here, and it's B is equal to $20 minus $7 is $13. So the cost of the big is 13, the cost of the small is 7, and this you have to report both. Whew, let's keep going. Stocks. Ms. Patel invested a total of $825 into 2 stocks. At the time of her investment, one share of the stock A was valued at $12.41, and a share of stock B was valued at $8.62. She purchased a total of 79 shares. All right, I just saw the word total twice. I think we're going to write 2 different total equations. So how many of each is purchased? Well, let's start there with the question. How many of each was each stock? And we want to know how many, the number of stock A shares and B. So the variable A is going to be the number of stock A shares, and the variable B is going to be the number of stock B shares. Over here it was a price. S and B were prices, but here A and B are just going to be how many stocks. What do we have here? Next, let's list out the givens. We've got a whole bunch of numbers. First of all, we do know the price at this point, $12.41 a share, $8.62 a share. And we also know a total number of shares, and a total dollar amount. So let's write one number of shares equation and one total dollar amount equation. So here you can see we've got a total of 79. That translates to this equation. The number of stocks we have, A, plus the number of stocks we have, B, is going to equal the total number of stocks we have, which is 79. Then the dollar equation is similar. We have a total of $825, and we don't know how many, but we do know how much they cost. The cost times how many plus the cost times how many is going to give our total. All right, substitution as a technique does require that we solve one of these equations solve one of these variables for itself. Notice it was a step over here, getting B all by itself. This was advantageous because it already started it like this, C. So let's go ahead and let's pick one of these variables to solve for, to get it by itself. And here what I chose to do is just subtract A from both sides. You could have equivalently moved B to the other side and done the entire equation, got the same answer. But we're just going to move A over, and then that means that B is equal to 79 minus A. I'm going to write the next equation, the total dollar equation here, and instead of writing B, I'm going to write what B is equal to. I know that B is equal to 79 minus A, so instead of writing B, I'm going to write 79 minus A in parentheses. Very important. So, and like I said before, it looked like it might be looking more complicated, but it's actually great because it's only one equation and one unknown. I'm going to distribute. I'm going to combine like terms. 1241A minus 862A happens to be 379A. And then I'm going to undo the addition. And then I'm going to undo the multiplication. We get to 38. Okay, you might think we're done, but we're not. Although we have A, we also got to figure out what B is. But that's okay. We can plug it back in to this particular equation, which I think is easiest. You could also plug it into this one and solve, but I think, or even this one, and solve the top red or the top blue. But I think this one is easiest for me. So B is going to equal 79 minus 38, which is equal to 41. So how many shares? We got 38 A shares and 41 B shares. As an audio check, I just wanted to say my favorite group costume I've ever been part of. My senior year in high school, all my friends and I dressed up as the Addams Family, and I used to be the dad. I forget the dad's name. Y'all, tell me what you're being for Halloween this year if you know, or what your favorite costume ever was. Take care, and I'll see you in class.